Okay, let's talk AGP 9. The latest version of the Android Gradle plugin from Google comes with some significant changes for Kotlin projects. First, all Android apps should start using AGP 9's built-in Kotlin support. And second, Kotlin Multiplatform projects that target Android will need to migrate to use the new Android KMP library plugin. In this video, we'll take a detailed look at both of these changes and see how you can migrate your existing projects to AGP 9. Of course, there's also plenty of written guidance for this, which I'll mention several times in this video, and you'll find all the relevant links in the description. You can temporarily opt out of these changes in AGP 9, but you won't be able to do that with AGP 10, which is coming sometime in the second half of this year. So I would recommend doing the migration work rather than opting out. Another important note here at the start. At the time of filming this video, we are still working on supporting AGP 9 in IntelliJ IDEA, and we expect this to be ready sometime in the first quarter of this year. Once that's done, we'll be releasing updates to the KMP wizard, as well as our samples and documentation to use AGP 9 across the board. So newly created projects from that point on will already include all the changes introduced by AGP 9 that we're about to go through. Let's start with the simpler change, which applies to all Android projects. Built-in Kotlin. Previously, you had to apply the Kotlin Gradle plugin, specifically its Android variant, to add support for using Kotlin in Android apps. Since Android has been Kotlin first for many years now, it makes sense to just include this by default. So with AGP 9, Kotlin support is built in, which means you no longer need to add the Kotlin plugin yourself. To adopt this change, the main thing you'll need to do when upgrading to AGP 9 is to remove the explicitly applied Kotlin Android plugin from your project. You can do this by removing it from your build.gradle file, and then if you use a version catalog, you can also remove it from there, as well as, of course, your root level build.gradle file. While the migration is as easy as that for a simple project, you might have to update some other bits of your configuration as well. For example, if you're using the Android Kotlin options DSL to set certain values, you'll need to move those to Kotlin compiler options instead, as you can see here. If you're still using CAPT, the Kotlin annotation processing tool, then first of all, you should strongly consider migrating to KSP Kotlin symbol processing instead, which is much more efficient, and almost all libraries that use annotation processing now support it. But if you really need to keep using CAPT for some reason, please leave a comment telling us why, and then check out the documentation to see how you can add the legacy CAPT plugin, which can still be used with AGP 9. Similarly, if you have custom source directories set up in your project, you'll find info in the docs about how to configure those with AGP 9. If you have a lot of modules to migrate and you can't do it all at the same time, you can temporarily opt out of using built-in Kotlin by setting the Android built-in property to false, which will opt out all of your project modules. Then you can migrate module by module by manually applying the built-in Kotlin plugin and going through the migration steps in the build configuration of every module. Once you've done that in all modules, you can clean up all of this temporary setup by removing the Gradle property and the manually applied built-in Kotlin plugin from the entire project. We'll see a brief example of using this mechanism in the second half of the video where we talk about KMP projects. Finally, while we're at built-in Kotlin, I should mention that AGP 9 depends on Kotlin 2.10 by default. Now, it's quite likely that you'll want to at some point bump the Kotlin version to a newer one than what AGP gives you. You can do this while still using built-in Kotlin by just loading the Kotlin Gradle plugin with the desired version in your top-level build file. For example, you can explicitly put it on the build script class path with a given version, like you can see here in the documentation. For an even simpler solution, if you already load a Kotlin plugin in your project, for example, the Kotlin Multiplatform plugin or the Compose compiler plugin, then their version will also override the built-in Kotlin version. In this project, for example, I'm using the Compose compiler plugin, which is using a version variable and is set up to use Kotlin version 2.3.10. I have this plugin loaded in my project in the top-level build.gradle file using apply false, and having this in place will automatically set the version of the Kotlin Gradle plugin to 2.3.10 as well, overriding the version that AGP provides by default. So if I ever want to bump my Kotlin version, I can do that by just changing my version in the version catalog. Nice and clean. For those curious, this works because Kotlin plugins like these all depend on the Kotlin plugins BOM. So loading any of them will add the BOM to the project as a dependency and align the versions of all Kotlin plugins automatically. Moving on to the larger changes, let's see how AGP 9 affects Kotlin multiplatform projects. Previously, AGP contained two plugins that you could apply in your modules to make them Android modules, an application plugin and a library plugin. Modules that use the application plugin would be, well, applications. So you can build those into an APK, launch them on a device, and publish them to a store. And then you'd use the library plugin for all your other modules that are there to just modularize your code base, or you would use this if you are actually publishing libraries instead of an application. If you were using AGP in a multi-platform context, you could add the Kotlin Multiplatform Gradle plugin from JetBrains to both of these types of modules. Now, with AGP 9, the regular application and library plugins are no longer compatible with KMP, so you cannot use them in a module that also uses the Kotlin Multiplatform plugin. Instead, the application module has to become a pure Android module, and any library modules need to move from the Android library plugin to AGP 9's new Android KMP library plugin. Before we get to the details, I want to mention at this point that AI agents can also do a pretty decent job of this entire migration on their own. For example, from the initial state of my sample here, I can ask Junie to migrate to AGP 9, pointing it to our blog post as a resource. And it does the entire migration of pulling out the application module and migrating to the new KMP library plugin in just a couple minutes. Of course, this is a simple project, but even in a more complex scenario, an AI agent will probably get you most of the way at least, so it's worth giving them a shot. Now, let's see what this migration looks like in detail, starting from the application side. It's common for existing KMP projects to have the Android application plugin applied in the same module as the KMP plugin. For example, many projects use a composeApp module with this kind of setup, containing shared code for all platforms, as well as the entry point and build configuration of the Android app. If you have a module like this, you'll first need to create a new module for the entry point of your app and apply the Android application plugin there. This new module can often be relatively small and simple, containing just the build configuration to package an Android app and files like the manifest, app-related resources like the launcher icon, and classes like main activity. The module that contained the shared code becomes an Android library that the app module depends on, and I'll actually rename that to shared, as it no longer contains a runnable application. Note that this library module here is still using the regular Android library plugin instead of the new KMP library one. We'll address this in the next section. Before that, let's see what these application changes look like in practice. The exact steps will of course be different for each individual project, but this will give you a good general idea of what the migration looks like. Before we get to making changes in this project, I will note here that I have already bumped all of my other dependency versions. So I've already updated the versions of Gradle, composeMultiplatform, and my Kotlin version to the latest available ones to make the AGP migration easier. Let's get to updating AGP then. First, I'll go to my version catalog and bump the AGP version there to 9.0. Then I'll open my Gradle properties and add BuildInKotlin false and newDsl false flags. Next, going back to our version catalog, we'll need to add two new plugins here that we'll use. One of them will be the Android library plugin, which we'll use for the multi-platform parts of our code. And the other one will be the android.builtInKotlin plugin, which I'll apply manually for a start here. So that's android.builtInKotlin. Both of these use the same version as your AGP version. Since we added some new plugins to the project, we'll need to hop over to our top-level build.gradle file and make sure that we load these plugins there like all the other ones. So we're going to be loading the Android library plugin and the Android built-in-Kotlin plugin. After a quick Gradle sync, we can now create the new Android app module that will serve as our application. I'll do this all from scratch, so I'll just create an empty directory and then create a new build.gradle.kts file here. We'll of course want to add this to our project, so I'll make sure that it's included in the settings.gradle file. Let's see what we need to configure this application. Most of these things we'll be able to move over from the composeApp module's BuildConfig. For example, we can grab all of the plugins from there and see which ones we'll need in this one. This will be a pure module with only Android code, so we don't need the KMP plugin. We also don't need the CMP plugin, but we do need the Android and the Compose compiler plugins, and we'll also need to add the built-in Kotlin plugin manually for the time being. Then we can look for dependencies that our Android app uses, which are currently listed in the composeApp module under Android main and common main. It's likely that we don't need all of these dependencies in the Android app module. We'll probably only need dependencies like activity compose and maybe a couple others, but to keep things simple here, I'll just move all of these over to the Android app module as well. But of course, later on, we should go through this list and remove the ones that are not actually necessary for this module. Hopping back to the composeApp module, we can also grab the entire Android block from over there and copy that to configure all the Android related bits of the app. And this should be good to go as it is. Of course, we also want to connect these two modules. The application should depend on the library, so we'll also add an implementation dependency on the composeApp project from here. This completes the setup of our new module, but we also need to change the existing module so that composeApp itself is no longer an Android application. Instead, we want this to be an Android library, and we need to make a couple corresponding changes. If we scroll down to the Android block, we should probably give it its own namespace. I'll call this just kmp-app.Android. android.shared. We should also remove properties here that are only applicable to Android applications and not to libraries. We can remove the application ID, the target SDK version, as well as the version code and the version name settings. With these changes, we should be able to successfully sync our project again. With the build configuration complete, we can start moving source files over to our new application module as well. I'll go ahead and create a new directory there, which is going to be the src main Kotlin directory. And I'll also want to move resources over, so I'll also create the corresponding folder for that. If we take a look at the contents of the composeApp module, in the Android main source set, we have the activity and the application classes defined. So I can just grab these and move them over to be in the Android app module instead, as they don't really relate to the shared part of our code base. We can also do the same thing for all of our resources in this example. So I'll just grab those and move them from composeApp to Android app. And we can also do the same thing with our manifest file, as we are now defining our application in the Android app module. This, of course, leaves us with an empty Android main source set, but I can leave this in place in case I need to access something platform specific in the library module later, for example, by using expect actuals. With the entry point of the app successfully moved to the Android app module, we can now select the correct run configuration and actually build and launch this app. As you can see, the app launch is expected, so we have successfully migrated to a new application module. Since the composeApp module no longer contains a runnable app, I'll also rename this to be just shared instead. This will require me to do some cleanup. For example, I need to update some references in the build configuration. And if we do a quick search for composeApp, you'll see that I'll also need to update some of my Xcode configuration, as well as the generated accessors for Compose Multiplatform resources that are used all over the project. So I'll just quickly swap all of these out now. We can then run a Gradle sync and a quick build to check that the Android app still builds as expected. Then, since we also updated parts of our iOS configuration, we'll also build and run our iOS app just to verify that it still works. With that, we've extracted the Android application plugin and the entry point of our app to a new module. Next, we'll need to migrate our library module. If you have a module in your project that uses the Android library plugin together with the Kotlin Multiplatform plugin, like we do now, you'll need to migrate that module to use the new Android KMP library plugin if you want to upgrade to AGP 9. This means that you'll have to update the build configuration of your existing module. But generally speaking, there are no further changes required to your project structure or your source code for this. There is also an official migration guide for this in the Android documentation, which of course you'll find linked in the description below. At a high level, what we need to do here is this: apply the new plugin instead of the old one, replace the Android target block used with the old plugin with the new plugin's Android library block to set up the Android target, and update any existing Android related config in our module to use the new plugin's DSL. There are cases where you'll need to do some additional work on top of this, but we'll get back to these in a bit. Before that, let's see what this migration looks like in practice. We'll continue from where we left off, with the Android application already extracted to its own module, and a shared library that uses the old Android library plugin, as well as the Kotlin Multiplatform plugin in the same place. The first thing we'll need to do is set up the new KMP library plugin in our project. So I'll go back to our version catalog once more and replace the Android library plugin with the Android KMP library plugin. Then we'll make sure that we're applying this new plugin instead of the previous one. We'll do this first of all when loading our plugins in the top level file. So we'll use the Android KMP library there, and we'll also do the same thing in the module level build.Gradle file. Since we now actually want to adopt the new plugin and its new DSL, we can go to our Gradle properties and remove the new DSL equals false option from there. As I mentioned previously, the main migration step is replacing the Android target block with the Android library block. So first of all, we'll change this to Android library, and then we'll move all of the things that were previously configured in the separate top level Android block into that Android library block. So I'll just grab all of these things here, remove the top level Android block entirely, and move all these things into Android library. This is the point in the migration where we start running into the interesting bits, as there are features of the old Android library plugin that the new Android KMP library plugin doesn't support. So you'll need to apply workarounds for them. And there are also features that the new plugin has turned off by default, which means that you might need to explicitly enable them if you want to keep using them in your project. All of these topics are of course covered by the Android documentation, which is linked below, but let's take a look at the ones that we need to use in this specific sample, as well as some other common ones that you might run into. A major change compared to the Android library plugin is that the KMP Android library plugin only uses a single variant. So you can't have product flavors or build types within your KMP module. This project doesn't really use variants here, so we can just remove anything related to them, which means getting rid of the default config block here and just setting the min_sdk level without that wrapper. While we're here, we can also get rid of the packaging block, which was specifically for packaging the final application, so we don't need to set that at the library level. Our project also doesn't compile any Java sources, so we can just remove the compile options that relate to Java specifically. Getting back to variants though, if you do actually use them in your project, one option that you have is to move the code related to them up into your application module, which of course can still use variants. Or if you can't do that in your project, you can create a new pure Android library module with the regular library plugin that still supports build variants, and then the KMP module can depend on that library from its Android main source set. If you want to see an example of how this can work, I've published a small sample on GitHub that creates exactly this kind of structure with a new Android library module and uses build types to inject some different values using BuildConfig. The specific use case of setting up BuildConfig style values is of course very popular on Android. And if you don't want to create an additional library module to use BuildConfig, you can look at third-party plugins like Gradle BuildConfig plugin or BuildConfig with a K, which can help you achieve the same thing in a KMP project. And while we're talking about variants, AGP 9 also deprecated the applicationVariants API. So if you use that anywhere in your project, you should replace it with the new Android Components API. Resources like the Gradle recipes repo can help you with this, and once again, you'll find all of these links in the description. Getting back to our sample, it still doesn't sync successfully, as we have also used the debug implementation method here to include the dependency for compose previews only at development time. However, since we don't have variants, we can't use this anymore. Instead, we should use the Android runtime class path method. This will make sure that it still works with our previews, but it will be excluded from our release builds. If you're using Compose Multiplatform previews in your common code and you're upgrading to AGP 9, you'll also need to update your Compose Multiplatform version to 1.10 or later and adopt the new commonized Android X preview annotation. To help you with your preview setup, we also have a shiny new documentation page where you'll find all the necessary info to update your build configuration. With this, our sample project builds again. However, it crashes at runtime. If we take a look at Logcat, we'll see the exception that tells us that the problem is with using resources. The reason for this is that using Android resources in the res folder is disabled in the new plugin by default. And this also affects using Compose Multiplatform resources, which are in the Compose resources folder. If you want to enable processing and loading of resources again in a module, you can do that by going back to your Android library block and then setting up Android resources.enable and setting that property to true. With this, we have completed the migration of our sample, and if I rebuild the app, you'll see that it now builds and runs as expected. We have just one more thing to clean up in the app. We can go to our Gradle properties and enable built-in-Kotlin again, which means removing the setting that set it to false, and then removing the manual applications of the built-in-Kotlin plugin from everywhere. So we can go ahead and remove that from our catalog, as well as from the module and the top-level build.gradle file. And if we sync all of this, we should still have a working application. With that, we are done with migrating our sample. But before we wrap up, let's take a look at a couple more common things that you might need to update in your own projects. In the new plugin, both unit tests and instrumented tests are disabled by default. These are called host-side and device-side tests respectively here. If you want to run these with your Android target, you can use the with host test and with device test functions to enable and configure them. If you have a library that ships ProGuard rules to your consumers, make sure that you explicitly enable publishing those rules when using the new plugin. You can do this within the optimization.consumer keep rules block, where you have to set publish equals to true and specify the file that contains your rules. Finally, if you want to use native builds with the external native build mechanism, the story is the exact same as with build variants. While the new KMP library plugin doesn't support this directly, you can create a pure Android module that includes the native build and then depend on that with your KMP module. Besides these changes in AGP 9 itself and your direct usages of its APIs in your build files, you'll also want to make sure that any third-party plugins that you use are also compatible with AGP 9. Most plugin authors have already updated their plugins at this point, and there is a great page maintained by the community where you can check which versions of third-party plugins are known to work with AGP 9, and what workarounds are possible in case a plugin doesn't fully support AGP 9 yet or has known issues. Hopefully though, you'll only need to bump the versions of the plugins that you're using. Alright, we covered a lot of the common migration steps for AGP 9 in this video. There are still a lot of small project-specific nuances that you might run into during this migration, so make sure that you take a look at all the resources in the description below, where you'll find a lot of useful info about how to migrate everything, including all of our updated content for AGP 9. Once again, if you're watching this early on, IntelliJ support for AGP 9 is still in the works, so as soon as that's published, we'll be updating our wizard as well as our samples to use AGP 9. Make sure that you're subscribed to the channel, as we also have some changes coming to the default KMP project structure soon. Don't worry though, all of those changes will be optional for existing projects. And of course, I'll explain them in detail next time. For now, thanks for watching, hope you found this overview helpful, and as always, have a nice Kotlin. Are these good takes? I don't know. I don't know if they are.